Hey, welcome back. This is now section 2.1, the addition property of equality. And what we want to do eventually is solve equations. And we begin with just a definition of the linear equation. Okay, so the linear equation, as I'm sure I noted in class, has the form ax plus some letter b equals c, where a, b, and c are just real numbers, and x is a variable, and a is not equal to 0. Okay, so if you can move things around a little bit, but this is kind of the standard form. So if you look on the right on question 1, let me, I'm trying to avoid my email, sorry. I can't find what happened to the little tab thing. Oh, okay. So determine whether the given equation is linear. So long as it's in this form, you're going to be good. If you see anything kind of weird, you're going to automatically kind of conclude it's not linear. So you have two choices, either nonlinear or linear. And in this case, it's clearly linear. You could put the form right underneath the x plus b, or you can put the equation right underneath that form and kind of see, yeah, it looks kind of the same, you know. So it must be linear. And check it, and sure enough. So some of these get a little weird. This one here, 5x squared minus 3 equals 12. That's nonlinear because of the exponent on the x, right? So it's written 5x squared minus 3 equals 12. This is nonlinear due to that exponent, that 2 right there. Okay, so it's nonlinear. This guy, again, is nonlinear because of the fraction bar. This one looks really odd, but it's actually linear because it has that form ax plus b equals c. So you have square root 3x plus pi equals 0.6 repeating. So the a is the root 3, right? The b value is pi, and then the c value is that repeating decimal, the 0.6 repeating, and they're all real numbers. So the thing is, we're probably not going to be using, roots, irrational numbers, and repeating decimals in our equations. But it turns out then that this guy is linear, and it gives you the choices there. This one is definitely not linear. It has that absolute value, x plus 7 equals 5. So the absolute value signs, basically that's a way of measuring distance on the number line. So it's a distance from 0. So you may remember things like so -2 here, -1, 0, 1, 2. So the distance from -2 to 2, you can figure out by taking the absolute value of the difference between those 2 points, right? So -2 minus 2 is -4. And then with absolute values, you just take the opposite. You take the negative of, in this case, the negative of -4. In other words, you turn it into a positive number. If it was +4, the absolute value of +4 would also equal 4. But anyways, it's a measure of distance. It's the distance from -2 to 2, and you can literally count over. It's 1, 2, 3, 4 spaces. So it's a distance formula, but it's not linear. You'll be able to tell a little better once we get into more graphing, and you'll see it's linear guys are equations of lines. You see that word linear. So why does it have the word? Why is it called a linear equation? That word linear has the subword line in it, and when you graph these things, they'll be basically equations of they'll be lines, right? So you'll go over the graph it, and you'll just have a straight line in there. The absolute value thing is going to look like a caret, so it's not. I mean, it has components of lines in it, but it won't be a straight line. So I mean, I'm not gonna beat you up over this because a lot of this stuff, it's kind of like, well, how do I know it's not linear? I don't even know what it is, you know. But I don't know. Anyways, once you get a little more comfortable with examples of linear equations, we'll put that to the side and kind of forget about it, and then we move on to solving these linear equations using the addition property. So basically, you can always add things to either side of the equation, and our goal here, so we'll have a goal associated with this. Our goal is to have x equal to something, right? So in order to get x all by itself on one side, in order to isolate x, you can add anything to both sides of the equation, right? So if in this case, you have to think a little bit, right? If I add in 6 on the left side, it'll create a cancellation, and you'll just end up with x on the left. Okay. The addition property says if you add 6 on one side, you then have to kind of add it in on the other side to balance things out. And so at the end of the day, x minus 6 plus 6, you add the negative 6 and the 6, and you get 0. So it'd just be x plus 0, which is x. And then on the right-hand side, you'll have 30. Okay, so the answer they want is 30. It says solution set. That just sometimes you can get actually more than one answer. We don't deal with that right now, but eventually we will. On my test, you could just write x equals 30. You don't need solution set. We don't need to be that technical about things yet. Okay, let's check the answer, make sure I'm right. Yay! Okay, and that's pretty much the idea, I think, through a lot of these problems. Don't be afraid of different variables and stuff. It's just the same game. Let's look at number 9. Okay, these are all WebAssign or MyMathLab problems. Number 9, negative 21 equals x minus 16, right? So again, the idea is to add something in on both sides to isolate x. And in this case, we can add in 16. A shorthand notation for doing this, I probably said in class, is to write the plus 16 below the equation. Okay, so you don't have to do it like I did above, unless you want to. If you want to do it like this, you can. It might slow you down, though. So what we generally do, if you need to, is just write plus 16 on both sides. So on the left, negative 21. Let's go ahead and do a little bit of arithmetic here. So 5 negative. And then on the right, negative 16 plus 16 is 0, so you're just ending with the x. So the answer is negative 5. For us English speakers, we like to go from left to right. So generally what we'll do is put the x on the other side. And you could always do this. You could always flip-flop the equation. You could put everything that's on the right onto the left, and then put everything on the left onto the right. Okay, and those two statements are equivalent. So the solution set is negative 5. And the solution set, again, it's just all the things that x can equal. Okay, there's a z. Now, the answer there, you just subtract 6 on both sides, you get z is 6. So you can probably do some of these in your head. Fractions, so they're trying to give you a little more practice with fractions. Let's try this one. So I got x plus 2/3 equals 5/3. And so I'm going to subtract 2/3 from both sides. Usually when I do this, I usually have a little bit more work to do if I don't have a common denominator, right? Here I have a common denominator though, so it's pretty simple. I just subtract the numerators over the common denominator. So it would be 5, minus 2 all over 3. So x will equal 3 over 3. So x will equal 1. One issue about notation that I see a lot of students do is they'll I don't know, it's like they'll start. Okay, so let me rewrite it and show you what not to do. Do not do this. Do not. So you have x plus 2/3 equals 5/3. And then they'll write equals x x equals 5 minus 2 over 3 equals 3 over 3. I don't know. It becomes really hard to understand. I think what they're trying, what some students are trying to do is work with an expression. But with the equation, you don't do that, right? You don't write it out going from left to right. You just skip a line and rewrite the equation every time. So if you want to go from left to right, like maybe you run out of room at the bottom of the page. So here, let's pretend, I have x equals 3 over 3, and I'm running out of room. I don't want to. I kind of want to avoid, then writing equals again. What I do is usually just take an arrow and then move it over to somewhere where I can work more with it and rewrite the equation again. So you're always rewriting the equation every step, okay? And it's just a readability issue. If you're like a super math genius, but nobody can understand your work, that's a huge dilemma for us, right? We want to be able to understand your work, otherwise it's not worth anything to anybody. So make sure that you're presenting your work the way I present my work. That's usually the kind of the best way to go about it. It's just to kind of try to imitate your teacher as much as possible. Okay. So anyways, that being said, here we have one that doesn't have a common denominator. Let's see if we find one that's a little uglier. All right, so let's try number 14. So I have x minus 33 over 14 equals 3 over 7. So this time I'm going to have to find a common denominator, right? So plus 33/14 on each side. So on the left, it's just going to be x. But on the right, you have a bit of work to do. And I mean, you can kind of find the common denominator here if you want. So in the first fraction, I'm going to have to multiply top and bottom by 2. And then kind of do it in your head. So it'll be 6/14 plus 33/14. Or you can rewrite it. There's nothing wrong with just rewriting it again. 6/14 plus 33/14. And again, I always am rewriting the equation. So if I run out of room, I'm going to do a little arrow and then write x equals 6 plus 33 is 39 all over 14. And then we go over here and plug in our answer. As you're going along, it says to always check your solutions. So let's try checking our solution in one of these, okay? I'm bad at that. I don't always check my solution. I would rather just go watch TV, so I apologize. I should be checking my solutions. And I don't exactly need to see the solution checked, like if you're on a test and you're like, oh, does he need me to? No, I don't really need to do it, because you could always be doing it in your head, and I would never know, So anyways, let's work on this. Plus 2/3 on both sides. So on the left, I have y. On the right, let's see, I need to find a common denominator. So this guy needs 3 in top and bottom. This guy needs a 5. And then I'll rewrite the fractions. So negative 12/15 plus 10/15. And then y will equal, I mean, sometimes I will just put another equal sign right here if it's just a simplification issue, but let's in general, a rule of thumb is just make a new equation, So anyways, negative 12 plus 10 is negative 2 all over 15. And that would be our answer. Let's check it. Okay, so I'm going to tell my reader that I'm going to check the solution. So always kind of in the back of your mind, somebody is going to be reading your work, right? I mean, what's the point of just doing it in isolation? Anyways, if it is a solution, both sides will be the same. So anyways, on the left, I need a common denominator, so I need a 5 and top and bottom there. So it'll be negative 10/15. Plus minus is a minus. You're just subtracting. 2/15 equals negative 4/5. So that would be negative 12/15 equals negative 4/5. And then on the right side, you can multiply top and bottom by 3 apparently, just to see if they're the same. Or you can reduce the left side. Maybe that's probably a better idea. Let's do that. So on the left side, you could simplify 12/15 divide top and bottom by 3, right? So 12 divided by 3 is 4, 15 divided by 3 is 5, and of course we get negative 4/5 equals negative 4/5. So it works. It is a solution. There's no doubt in my mind that negative 2/15 is going to be the answer. Okay. Okay, there's a decimal, so you gotta work with decimals sometimes. There's another fraction, weird variable n. That's okay though. Don't let it confuse you or scare you or anything. 28. You can make up your own variables if you want. So I was playing around with Cherokee over the break. Cherokee language, the American Indians, not all of their languages I think are written, but Cherokee has a written version. It has its own letters and stuff. You could look it up on the internet. It's pretty neat. But you can, make up your own symbols. So a weird symbol I was seeing over the break was this symbol. Kind of looks like a fork. Okay, let me add 49 to both sides. So 9 plus 8, 7, carry the 1, 4, 5, 6, 7. So fork equals 77. In other words, fork equals 77. I think it's a psi. It's a Greek letter. I don't know. But anyways, n in this case will be 77. So don't let those weird variables scare you. Let's keep moving on here. Another decimal. Oh, this one is kind of, I probably did it in class. I'll do it again just in case I skipped it or didn't get to it. But number 22 is kind of scary. So we have negative 2.6 plus m equals negative 2.6. So I'm going to add 2.6 to both sides. And what do you get? M equals 0. That's fine. You can have 0 as an answer. That's not an issue. The answer here, the solution set, is just the number 0. Yay. Okay. This next kind of set of problems, you have to simplify both sides of the equation first before you sort of solve. So simplify, do any distributions, combine like terms, all that jazz, right? So anyways, let's look at 23. And we have negative 3p plus 8 plus 4p equals 11. So on the left, we have like terms, the negative 3p and then the 4p. So you got negative 3 apples plus 4 apples. I guess you have 4 apples and you're taking away 3 of them. So you end up with 1 apple p, 1p, but we just write p, not 1p. 1p looks a little funny, so we put just p. And then plus, sorry about the weird colors, plus 8 equals 11. And now it's in kind of our traditional form, the linear form that we introduced above. And we know how to deal with it. So you'll have p equals 11 minus 8 is 3. And again, you can check it if you want to be absolutely sure. You don't want to mess up your answer. Here's another hard one. So number 24. Again, you want to simplify both sides of the equation before you get carried away. So 7 minus 4x plus 10 plus 2x plus 3x minus 4 equals 2 plus 3 times 5. Okay, so I go through and I just find my like terms. Here's all the x material, and you add their coefficients, the numbers in front of them. So you get negative 4 plus 2 is negative 2. Negative 2 plus 3 is 1, so I have 1x, which we just write x. And then I add all the constants together. So 7 plus 10 is 17, minus 4 is going to be Sorry, there's like 20 phone calls. My stupid cell phone's going off. All right, sorry. So what do we have? 17 minus 4 is 13. And then on the right side, you got the order of operations. Please excuse my dear Aunt Sally. So multiplication comes before addition. So it'd be 2 plus 15. And then rewrite the equation. Okay, 2 plus 15 is 17. And then finally, we can move the 13 over. And I'm going to use my arrow because I ran out of room. And I have x equals 4. Okay, so let's put 4 in there. Check my answer. Yay. Okay. This 25, you have stuff. It's like you have variables on both sides. Okay. And the idea is to get all the variables onto one side and then isolate the variable. Okay, so here we go. So first what I'm going to do is move the 3y to the left side. Okay. So I got 4y minus 3y is 1y. Again, we just write y plus 4. And then on the right side I have negative 3. And now you got it back into that standard form that we're used to, and we know how to solve this. So a lot of math works like that. You're trying to get things into something familiar, trying to push it into a form that's familiar, that we already worked with, and we know how to deal with. So you got negative 4 on both sides, minus 4 on both sides. Negative 4 minus 3 is negative 7, and I believe that will be our answer. Okay. Okay, so a bunch of those guys. So this one's getting more complicated now. And again, you want to simplify both sides of the equation before you start moving things around. Okay. Okay, so I'm not going to add the 7 over or move the 4x over. No, slow down. Okay, I'm going to first try to simplify as much as possible. So on the right, that means distribute. And then again, I got another simplification I could do on the right. I can add the constants together, the negative 9 and the 7. Oops, let me go back to purple. 3x minus 2, and then I try to collect all the variables on one side. 4x minus 3x is 1x. And then I want to isolate the variable completely. So I move the negative 2 over, and I'm going to get x equals negative 4. Yay. These are kind of weird, but it just goes to that idea, like back here with the fork. You can use anything, any symbol you want, and that's one of the powers of algebra. Back in the day when they did math, believe it or not, everything was written out. It was actually done in Arabic, right? So it was only later that they started putting in variables. I think the Arabic people initiated that, so they started working with variables, or maybe it was Europeans, I don't know. But yeah, originally everything was just written out in words, like word problems, and then they figured out that some word problems were kind of exactly the same with regards to how they worked. If you know how to do this word problem, you know how to do this word problem. And then they could just replace parts of the word problem with variables, and it became much more powerful. So you could kill a million birds with one stone, And that's what they're trying to get into your brain here. This is just the power of algebra. This stuff has been built over hundreds of years, thousands of years, and it's one of mankind's greatest accomplishments. So we want everybody to be aware of it and to learn it, and hopefully maybe someday apply it, or at least do something similar on your job to give you, give you a leg up, so to speak, to make you more a better worker and better than other people, so you can get better jobs. Anyways, here, what I want to do is isolate x. So what I do is just add the box on both sides. And then I end up with x equals triangle plus box. And part B. I like those questions. I would rather have those than numbers. Then we start getting in the story problems here at the end. That's all, you're always going to have that at the end of our homework assignments. So the last couple problems will be story problems. Anyways, the unknown number is always going to be x, so you're going to be using x in these things. But anyways, what do we have? Let x represent, yeah, okay. So if 11 is subtracted from a number, the result is -3. So a number, that part says a number there. Let's see if I can highlight it. Hopefully you can see that. A number, that's the x part. And we're saying we're subtracting 11 from that number. So you're not going to write 11 minus x. You take x and you subtract away the 11. And then the result is -3. So that phrase means equal, right? The result is, so x minus 11 equals -3. And then that's going to be your x minus 11 equals -3. And if you don't get it, there's a lot of things you could kind of do to help. I would go to the book. If you have a lot of trouble, I always went to the book, because we didn't have software back in my day. But you can go here and kind of hit the help me solve that, and it'll walk you through it. You got to be a little careful if you say ask my instructor, because sometimes it'll get lost in my email. If you really are really having help or having a problem, or you think the problem is just incorrect, which never happens, but some people think, it's like 12 o'clock at night and you don't know what's wrong, and you know there must be a problem with the software. But you can always, send me an email, but do it directly. Don't do it through the system, because it might get lost. So I don't know. See, I mean, you could try to send it to me, but just don't. Oh, it does go right to my email. Okay, you're cool then. You just send it that way. If you have a problem, that's probably the best way to do it. Hopefully, if I'm not responding to that, then there's an issue. You want to send me hey, why aren't you responding to my emails? Because I'm not. I'm looking at my email. Anyways, I screwed up. X minus 11 is write an equation. Oh, it's 12. Sorry, I don't know what must have changed. Sorry about that. And then they want you to solve it. So this is x minus 12, not 11. And then add 12 to both sides. So x will be 9. And we'll plug that in there. Check your answer. Yay. Okay. This one's a little harder because it got fraction in it. Let's see if we can bust this out real quick. So the difference between 6/7 of a number and 8 is 13/7. Okay, so this time you just write it down as you see it in order of the sentence. It's the difference between 6, so that's the first thing I write. It's not like the number 5 is subtracted from and you kind of reorder it. This time you just take it in order. So the difference between 6/7 of a number, the word of means to multiply. Okay. So 6/7 of a number, 6/7 times x, and you want a difference. This thing and 8 is, the word is means equals, 13/7 of a number. So again, 13/7 times x. Okay, so I'm going to write that out. 6/7 of a number, so that would be x times x. You don't have to literally put in, I don't think you have to put in times x, but you could just write the numbers next to each other, and it's implied that they're being multiplied. Okay, and then they want you to solve the thing. So you want to collect variables on one side. I'll go ahead and subtract the 6/7 x over. So get -8 equals, what is that, 4, 7. Wow, really? 7/7? 13 minus 6 is 7. Then so you have 7, 7x. 7 over 7 is the same as 1. And of course, we don't write 1 times x, we're just going to write x, right? And then you can flip-flop the sides. And so it's the same as x equals negative 8. And I'll pop that in there. Yay. Okay. Here's another kind of story problem. The beginning of mathematics is just mostly about recording money, people exchanging money and how much does this cost. I think they found like clay tablets from 3000 BC that had ledgers of financial transactions on them. So math has been around because of that, forever. Anyways, here this problem, it says the cost C of an item plus the markup M on the item equals the selling price S. So they give you this equation C plus M equals S. They tell you the selling price is 1,870. So the selling price is S. So they tell you S is 1,870. Then they tell you the markup is 130. So M is going to be equal to 130. And then they want you to find the cost, right? So all you're going to do is substitute in and then solve for C. Okay, and that should be then your answer. This problem, one thing you could do with math that is awesome is called mathematical modeling, right? So you'll have observed data. Like you can go out and collect data. We do it where I work. We collect grades of everybody. We want to look at, how well are the people in this age group doing in Math 0965. So we'll collect all this data and kind of look at it. And then we want to make generalizations based off of that. So we'll kind of build a mathematical formula, which may not be perfect, but it'll allow us to make guesses about other things, right? So the math becomes a very powerful way of dealing with reality. And here, that's kind of what you see. You have two things. You have the real data, which is this bar graph. Somebody went out and collected all this data and compiled it into a graph. And then you have this mathematical model that some, mathematician sat around and kind of figured out. You use statistics and stuff called linear regression and things like that, okay? So you have the real data, and then you have this mathematical formula that can be used to make guesses about the real data. Okay, let's read the question. So the bar graph shows a percent of college freshmen with an average grade of A in high school. The data displayed by the bar graph can be described by the mathematical model P minus 0.8x equals 15. And that's the equation I wrote down here on the left. I'm going to write out what the variables stand for. So x is the number of years after 1980. And you generally always want to define your variables in the beginning. So years after 1980. And then P is the percentage of college freshmen who had an average grade of A in high school. And I abbreviate a little bit. I'm not going to write it out perfectly word for word. Because this is kind of just for me, right? To an extent, I want other people to be able to read it, like my teacher and whoever's grading my work. But right now in my notes, I can abbreviate things a little bit. It's okay. Okay. So, anyways, part A. According to the formula, so not the bar graph, the formula, in 2010, what percentage of college freshmen have an average grade of A in high school? So in order to work with that, we need to figure out what x actually equals, because it's not, we're not going to put 2010 into our formula. X is the number of years after 1980. So in our case, it'll be 2010 minus the 1980. right? It's really wanting to know how many years after 1980. So 80, I can do that in my head, it's 20, 30 years. So it's not 2010 that I put in the formula, it's the 30 I put into the formula. So I'll have P minus 0.8 times 30 equals 15. And then I solve for P, the percentage, right? So here I'm going to go 0.8 times 30. Okay, so I have 0 and then 24. There's one decimal place moved, so it'd be just 24. P minus 24 equals 15. And then isolate P by adding 24 to both sides. So P is 39. So its answer is 39% of these college freshmen have an average grade of A in college, from high school once they get to college. Okay. I guess this next part says, does this underestimate or overestimate the percentage displayed in the bar graph? And then they want to know by how much. So our formula, it's a model of reality. It's not reality. It's just something that's going to help us work with reality. And if you look over to the bar graph at 2010, the orange bar, it says the actual percentage was 37. Okay, so our answer is really close, but it's an overestimate, right? It's 39. The result is an overestimate, and it's an overestimate by 2%, right? You just subtract 39 and 37. Okay, part B. Now they want you to use the formula to project something that even the data doesn't tell you. Okay, so that's one of the powers of these formulas. You can use it to make predictions. It's like being a sorcerer, somewhat. So part B, they want you to make a prediction about the freshmen coming in 2020, right? So here again, we need an X value, and I want to take 2020 and subtract away 1980. That will be just 10 more years, so that's 40. And then I'm going to plug it into my formula, and I can get a guess. It may or may not be correct, but it's better than nothing. You always want to have at least some strategy when you go out and do things, unless you have millions of tries. But if you have a finite number of guesses, you want to have some sort of strategy. Anyways, what do we have? 40 times 0.8. So again, I have 0, and then 8 times 4 is 32. Move the decimal over 1. So that'll be P minus 32 equals 15. Add 32 to both sides. So I'll get P equals 47. So 47%, they're saying in the future, 47% of the incoming freshmen in college will have an average of A in high school. So they talk about grade inflation and that sort of thing, but I don't know. Anyways, there's 2.1, and I hope that helps a little bit. And you can always pause my videos and rewind them and slow them down if you need to. But I hope that helps, and I'll see you next time.